All right. This lesson is about normal distributions and looking at what they look like and starting to look at percentile scores with them and other things that you will need. So here we go, normal distributions. First of all, you know that a distribution can be described by a set of data, by a stem plot, a box plot, a histogram, a line graph, different kinds of graphs. And so one thing you need to do is you need to graph the graphs, plot them on some sort of a graph. You're going to look for patterns of shape, center, spread. We've already talked about that stuff, outliers. Then you're going to choose to describe that graph with either the 5-number summary if it's skewed or the mean and the standard deviation if it is symmetric. Okay? So here's what you need to know. When you have a symmetric data, and it could look something like this happens to be a unimodal, it peaks in one spot type of data set. The median and the median are going to be the same. This is also true if you have a uniform distribution that looks something like this, remember, where it's sort of rectangular shaped. The mean and the median would also be the same, pretty much the same there. And you need to remember, you guys, that it is very, very rare to have a perfectly symmetrical, whether it's uniform or unimodal, but anyways, it's very, very rare to have a perfectly symmetric set of data. So even if it's roughly symmetric, you're going to look at the mean and the median, and they should be very close to each other. Okay? But over here on the right, when you have data that is skewed one direction or another, the mean gets pulled the direction of the skew. So the mean gets pulled to the right, and we kind of talked about that in our previous lesson, but just a reminder that the mean does get pulled to the right, the mean gets pulled the direction of the skew. If it is skewed left, the mean will get pulled to the left, and the mean would be smaller than the median. All right, so we have a set of data here, and I want you to just look and see if it would be smarter to describe this distribution with which type of description, and then sort of look at it, okay? So this one right here definitely is a graph that is skewed to the right, okay? Because it is skewed, you would not use the mean and the standard deviation, but you would use the median, or the 5-number summary, which is part of the 5-number summary. That would be how you would measure your center, and then your spread would be described by either the IQR or the range. Okay? That's how you would describe that set of data. Okay? Important to know, though, that the mean on that one is definitely bigger than the median. Okay? So if this is the median right here, the mean will be to the right of that because it is skewed to the right. Okay, if it was skewed left, the mean would be to the left of the median. This one is pretty uniform. It is not perfect, and we talked about how you're very rarely going to have a perfect set of data, but this one is definitely a uniform shape. It is pretty symmetric, and what I know then is that the mean is going to be pretty darn close to the median. Okay, and I also know that I would describe it with the mean and the standard deviation. The mean is how I would describe the center, and the standard deviation is what I would use to describe the spread. Okay, then we want to look at some specific kinds of data, specifically normal distributions today. Normal distributions are ones that are both symmetric and unimodal. They are bell-shaped type curves. You maybe have heard about that. But with symmetric and bell-shaped curves, the mean, the median, and the mode are all in the middle, okay? All exactly in the middle. And what happens with that is 50% of the data falls to the left of that mean, median, or mode, and 50% of the data falls to the right. Now we know, because we don't have always perfect distributions, that that's not going to be exactly right on every time, but it is a good model to use that we will use lots and lots to make some assumptions about our data. Okay? Normal distributions are really, really common in the real world. If you look at the heights of people, the size of things produced on machines, errors in measurements, blood pressure, grades on tests, all that kind of stuff, you will find that they fit into a normal model. Okay? Again, normal is symmetric, and it is also unimodal. Okay, because it is a normal curve is a symmetric curve, it makes sense to describe it with the mean and the standard deviation. Okay, the mean describes where the center is, and the standard deviation affects the width of that curve. Okay, so here's what I want you to notice. Let's say we were doing a situation and we were looking at, I have no idea, test scores, okay? So let's say the average test score was 80, and there was some people that got, 82, 84, 86, 88. I'm just kind of making this up. But let's say this was our situation that we were looking at, and this is what I would want you to know, okay? So here's the mean. The mean is right here at 80, okay? Let's say I give that test again, and I give the kids some 2 free points extra credit, let's say. I gave everybody 2 free points extra credit. Well, what that would do is it would raise everybody's score 2 points. And if it raises everybody's score 2 points, it takes this curve right here, and it moves it 2 points to the right. Did it change how different everybody was on that curve? No, it didn't change how different everybody was compared to each other. So the shape of the curve is not going to change. It will just shift to the right or to the left, okay? So that's what that does. Then the standard deviation, what that does is if everybody gets, for whatever reason, more clustered, if I gave this same test in a different class and people copied each other's answers and that kind of thing, then their answers would be more similar to each other. Their scores would be more similar to each other. I still might have a mean of 80, but if people copied each other and their scores were more similar, the shape of my curve would look something more like this. I would have less variability in my answers, so my standard deviation or my spread would be smaller. Okay, so that's how that affects that. Normal models we use to kind of make predictions and to make guesses and to weigh some choices that we might have to make, okay? So this is kind of what you need to know. On a normal shaped curve, what you do is you label the median or the mean or the mode, which is, again, this line right here. And you need to remember that this is sort of the 50th percentile. 50% of data will fall under this, 50% of data will fall below this. Then, with a normal curve, what you do is you measure in standard deviations, how many standard deviations fit on either side of the curve. So on either side of the curve, I want you to know that typically about almost all of the data falls within 3 standard deviations of that mean or the median. Okay? 68% of the data fall within 1 standard deviation, either 1 standard deviation above or 1 standard deviation below. Notice this -1 down here. This is negative because it's 1 standard deviation below the mean. This is +1 right here because it's 1 standard deviation above the mean. That's what those numbers mean on a normal curve. Okay, it's how many standard deviations are above or below the mean. 95% of the data fall within 2 standard deviations, either 2 below or 2 above. So if I were to pick something, it is pretty darn likely that I am going to be within 2 standard deviations of the mean on a normal model. And it is almost certain, not perfectly certain, but almost certain, that if I go within 3 standard deviations of the mean, any piece of data in whatever situation I'm looking at is going to fall in there. Okay, there's still some crazy exceptional pieces of data sometimes, but almost all of them are going to fall there. Okay. So this is kind of the normal model that we will continue to look at throughout the rest of this chapter. And so I'll just give you this graph and just so you kind of can see it all in one spot. You can see that 68% fall within 1 standard deviation, 95 fall within 2 standard deviations, and about 99.7 fall within 3 standard deviations. Okay? And again, I want you to know that this is a 50% line. 50% of the data will fall below that, 50% of the data will fall above that. Okay? 3 standard deviations, though, fit under the curve. All right, so we are going to use that to figure out what % of the data will fall below 1 standard deviation. Okay, below 1 standard deviation. So basically what I'm wanting to do is I'm wanting to figure out what % of the data will fall from here to here. Okay, what % of the data lie in this part of the curve? That's what I want to figure out, below 1 standard deviation. Well, you kind of have to use the tools that you know in the 50% line. Okay, I always work with the 50% line. And I know that from here to here is 50% because this is my mean, median, mode line right here. So I know that from here to here is 50%. And I know that from here to here, will be half of this 68% that falls within 1 standard deviation. So right here is going to be half of 68, and half of 68 we know is 34. Okay, and if I put this chunk together with this chunk, then I know that 50 plus 34 is 84% of the data will fall below 1 standard deviation. Okay. Here's another one. What percent of the data will fall above -2 standard deviations? So above -2 standard deviations, I would go like this. Above -2 then would be what percent of the data falls from here all the way over to here. In this area all over there to the right of that curve, above -2 standard deviations. Okay. Again, it is going to be 50% from here to here. Okay. From here to here is going to be half of that 95, and half of the 95 is 47.5%. So half of 95 is 47.5%, and if I add the 50 plus the 47.5%, I will get 97.5%. So 97.5% do that. Okay. One last example here. In this example, we're talking about Dutchmen. They are supposedly among the tallest people in the world. The average Dutchman is 184 centimeters tall, which is just over 6 feet in American terms. And a normal model is appropriate, and the standard deviation for men for Dutchmen is about 8 centimeters. Okay, so the first thing you're going to do is you're going to label your normal model so that it fits this particular situation. Okay, so the mean is 184 centimeters. And then the standard deviation is 8 centimeters. So you're going to go up 8 centimeters either direction to 192, 200, 208. And then you're going to go down 8 centimeters each way. So 184 minus 8 is 176, minus 8 is 168, minus 8 is 160. Okay? Then the question is, the first question we have to answer is this. What percentage of all Dutchmen will be over 2 meters tall? So first of all, you need to know that these units are in centimeters, and so it probably seems kind of weird that you're not seeing the number 2 on there, and some of you may want to use this number 2 right here. That number 2 stands for standard deviations, 2 standard deviations, and that's not what I'm asking you. I'm asking you what percent of Dutchmen will be over 2 meters tall. Well, just in case you didn't know, 2 meters tall is the same as 200 centimeters. Okay? So basically, I'm asking you what percent of the men will fall in this part of the curve over here. Okay? That's what I'm asking you. Well, here's what you need to know. From here to here, again, is 50%. Okay? And from here to here is half of that 95. So half of 95 is going to be 47.5. And I want to know this distance right here. Well, clearly to figure out what that distance is, I'm going to subtract 50 minus the 47.5, and I should get 2.5%. Okay. Same problem, I just labeled the normal model here so that we don't have to relabel it. Now I'm asking you what percentage of all Dutchmen will be shorter than 160 centimeters tall. Shorter than 160. It's not going to be very many men, that's for sure, but shorter than 160 is going to be just this little tail down here. And so you can see that it's going to be a super small percentage. But again, you're going to figure that out, and I always start with the 50. So from here to here is 50%. We know that from the mean or the median or the mode is 50%. Okay. Then this is 3 standard deviations below, so I'm going to use this 99.7. From there to there is going to be half of 99.7. Okay, half of 99.7. And then the difference here is what you want to find out. This is what you want to find out. So you're going to take 50 minus half of this 99.7 right here. Okay, and if you take 50 minus half of the 99.7, you should get 0.15%. So not even, just a little over 1/10%. Very, very, very few people are shorter than 160 centimeters of Dutch descent. All right, then this one. What percentage of all Dutch men will be taller than 176 centimeters, but shorter than 200? So taller than 176, but shorter than 200. So I want to know what part of the curve that is from here to here. Okay, so if I kind of color that in, that's what I'm trying to figure out. Okay, so taller than 176, but shorter than 200. All right, so taller than 176. If I go from here to here, that's within 1 standard deviation, which is going to be half of that 68%. So to figure out this much, I'm going to take half of 68, which of course is 34. Then this is 2 standard deviations on the 2 standard deviations mark. So from there to there, I'm going to take half of the 95, which of course is 47.5. Okay, so this is 34, this is 47.5, and I will add the 2 together, and I should get 81.5 centimeters. So the 34 plus the 47.5 should give me 81.5%. All right, and then lastly, what is the median height of Dutch men? Well, on a symmetric curve, the mean and the median are going to be the same. So if the mean is 184 centimeters, guess what? So is the median. And that hopefully will do it for this lesson, and we will see you next time.